All right, welcome everyone. Today we're going to talk about Django. Well, first of all, what is Django? And before I start going through all of our slide deck and everything else, I kind of want to take a little bit of a timeout to do a reference to something that we've worked with in the past. So in the past, we've worked with the Rick and Morty API to grab data. We read about their documentation, saw there's a couple of API calls that we can make to be able to receive dictionaries back as responses. Sometimes we get out dictionaries. Sometimes if there was an error, we would get something like a list listing all of our errors. Or sometimes we would just get a string telling us that something went wrong within this API call. But where did all this information come from? And how did this information actually become accessible to the front end? Well, we've seen this diagram before where we talk about our front end, which now we know we are building with React. And I could spell at one point. There's our backend, which we will be building with Django. And then there's our handy dandy database. So I'm just go RDBMS. Now we learn how to utilize our front end with React. And the process of fetching data is simply we made an API call to some sort of backend server. Currently, this backend server is being hosted on the internet at the following address. Right, so on the internet, in the following address, we would be able to find this server. That's where it's currently living. Well, when we contact this server, we also tell it, hey, I'm trying to access your API at characters and so on. All right. Well, that gets passed into the backend server, and the backend server kind of dissects this string that follows. And it says, okay, well, it wants to access our API views. And we're going to talk about what a view is. A view is essentially a function. And in this function, the specific function that we want to grab will be the one that matches characters. You could think about this as a dictionary. It's looking for a character endpoint, and that character endpoint matches the all characters view, or all characters function. When that all characters function is triggered, it made a call to our database. That call to the database was something like, hey, I want you to select all from characters. That then came back as a database query, which we've already seen every single time we've worked within PostgreSQL. But that data comes back. It's a database query, so how to get it turned into something that I can work with in JSON? Like, how does this happen? Where it turns into dictionaries and objects. Well, that process is called serialization. And finally, when this method is completed, well, this view, or excuse me, this function of all characters returns a JSON response. So currently we learned about how to interact with a backend server or an API to be able to grab information and be able to return it and actually generate a user interface. But now we're going to start learning about building this backend server, creating all these functions, working with serialization, and returning a JSON response. All right, does anyone have any questions as to what we're about to be learning with Django? Let's hear it, Alex.
So, is Django and Flash the same thing?
That's a great question. So Django and Flask are both going to be serving the purpose of generating a Python backend server. So their end state is pretty much the same. They're creating a server that can communicate to a relational database management system, and you could program it to either do server-side rendering or actually create API responses, which is the same exact thing that we're going to do with Django. The key difference between Flask and Django is that Django comes with batteries included. as we're going to see inside of the Django module, we're going to start importing a lot of information. That means that Django has already realized, hey, you know what? The majority of developers need these tools. And the majority of developers probably don't have the time to create these tools from scratch. So instead of making them do it from scratch, we're just going to make it for them. They could import it, leverage it, and utilize it to create their application quickly and efficiently. Whereas Flask does not have that. Flask requires you to create everything out of scratch or import outside libraries like SQL Alchemy. That didn't actually belong to Flask. That's outside of this spectrum of Flask. Somebody else generated it and allows people to utilize it within Flask. Does that answer your question, Alex?
Yes, and so maybe to reinforce it, maybe like I do remember we created some serialization functions in Flask. Would that be one of the things that's like pre-built in?
That's right. Yes. All right. Awesome. Hein, or excuse me, Cricket.
Django only for backend only.
So Django does have the capability of creating dynamic templates and template rendering. So you could make an entire full stack application in just Django. We don't recommend it because it's not as dynamic as React is. And pretty much the front end language nowadays is always React. So short answer, no. You can make an entire full stack application in just Django. Um, Long answer, here in this program, we're going to leverage Django only to create a backend API. Does that answer your question?
Yes.
Awesome. All right. Well, now that we know what Django is and what we're going to be learning, let's go ahead and start diving into our actual content. So why Django? What is Django and why use it? Well, Django is a backend Python framework. Django has something called an object relational mapping system. We're going to take a look at that in depth today. And it's super useful for creating RESTful APIs. We should have done some pre-reading regarding what a RESTful API is. And then it's versatile and portable. And we're going to see all of these as we're continuing to develop our Django application over these next couple of weeks. Now, let's talk about virtual environments. So for virtual environments, think about virtual environments as containers that wrap around your project to ensure that whatever you install inside your virtual environment stays there and doesn't affect the rest of your computer. And here we have a couple of examples, project 1, project 2, and project 3. Now, here's the way that I would like to explain it. When you create a React application, well, React comes in with something called node modules or dependencies, right? Hence why we run npm install whenever we create a React project. Now, when we have those dependencies, these dependencies are specifically for React. That's why we have to individually install dependencies per React project. Now, in Django, Django doesn't have something like this to be able to manage all the different dependencies. So instead, what we utilize is a Python virtual environment. You already have a Python virtual environment that's activated. But let's think about this in this process. Let's say I have a Django project, and I also have a Flask project. Both of these projects are created with Python, but there's a couple of differences between them. For example, let's say this one was created with Python 2, or let's say this one was created with Python 8. Meanwhile, our Flask project was created with Python 10. Here for dependencies, we know that Django is going to require Django to be installed. It may require something like PsychoPG to be installed. And maybe our Flask project or our Django project is utilizing PsychoPG too. In this case, we have Flask that needs to be installed. And maybe we're utilizing psychopg3. Now, all of these dependencies are just different versions of their parent, right? This is just an older version of psychopg. This is just an older version of Python. Well, if I were to install all of these dependencies inside of the same environment, my machine may become confused as to what Python version it is that it's going to utilize to execute code, what psychopg version it is that it's going to utilize to connect to my database. And my database may also become confused as to how to speak to psychopg because I have multiple versions of psychopg installed inside the same environment. So how do we manage this? Well, this is where Python virtual environments come in. So virtual environments would give me a lightweight version of Python, a light version of pip, and it would allow me to isolate dependencies. So although all of these dependencies are falling within my Django project, those dependencies wouldn't be held at the project level. They would be held inside of the virtual environment. And it would allow me to divide which dependencies fall under which project. So for example, right now, we all have our .default virtual environment that has a ton of things that we've installed, right? We've installed PyTorch, we've installed Flask into it, et cetera, et cetera. Well, we would simply deactivate the virtual environment that's currently working, and we would create a new one and then activate that new virtual environment to make sure that we're isolating dependencies. All right. Does anyone have any questions regarding Python virtual environments? Let's hear it, Tom.
When you deactivate and reactivate virtual environments, what happens to the dependencies that were installed in that environment? Because obviously we can reactivate the environment, but the dependencies, do they get like compressed or do they get stored in temporary so that way, if we don't do something with it soon enough, our computer might just look at it as trash and toss it after some time, or how
Yeah,
does that work?
that's a great question. So it actually falls inside of the pip3, and it's going to look a lot similar as to node modules. We're going to take a look at that here shortly once we actually create a new Python virtual environment and we start breaking down all the different scripts that are in there. All right, Alex.
Do I know we've had a virtual environment activated since like the start of the cohort. Um, this doesn't apply to like NPM.
No,
So
go ahead, keep
okay.
going.
So like we do npm install vite and all this stuff, and our virtual environment's activated. If we deactivate it and vite is still there.
Yeah, that's a great question. So when it comes to V is installed inside of Node, and Node is installed inside of your machine, right? And that falls completely outside of your virtual environment. Your virtual environment is only worrying about any sort of Python dependencies, such as PyTorch, psychopg, and Flask.
Okay.
Go ahead, Arnold.
Yeah, going back to what Alex said, so we've had the virtual environment on this entire time. So for Django, are we gonna have to activate another one, and do we have to do it every time we try to use Django?
We're going to talk about that here shortly, but the short answer is going to be yes.
Thank
All
you.
right. Of course. Any other questions? Okay, perfect. Let's go ahead and keep moving forward here. So here we're going to start talking about the Django setups. So when creating apps, we must ensure to apply the dry in each and every app function and or class. So dry means don't repeat yourself. An app should be fully dedicated to one purpose and one purpose only. And generally that purpose is a reflection of its main model. Well, what is a model? A model is essentially just going to be the data table that it's dedicated to. Now you may ask yourself, well, if my application has 10 different data tables, am I really going to have to create 10 different apps? That is going to be a design-based decision, and you're going to see as our projects evolve how much content is really created by just having one model, right? Because that one model is going to need a serializer, it's going to need API views, it's going to need URLs. The best way to do it is to isolate everything to ensure that if one thing breaks, it's isolated to that one app. And also just to make sure that your scripts are kept small. If you try to put more than, on average, for just one model, you're looking at about 100 lines of code per script. So we don't want to add more than one model per app. All right, so let's talk about the project structure here. So the Django folder structure. When setting up your Django project and admin application, try to keep the principle of OOPs in mind. All right. So here the project's going to be created. When we talk about the access point, everything that comes data-wise is always going to enter at the project level first. From the moment you run your server, and I know this terminology may seem a little bit weird right now because we haven't seen it in action. So just keep it in the back of your mind, and then as we go through the lecture, we'll go ahead and go into details as to how everything works. But from the moment you run your server, that is going to take a look at your project information. It's going to try to connect your database. If everything inside of your project succeeds, it's going to check all of the apps to ensure that they all succeed. And then it will automatically run your server with all the information being compiled. As requests come in, they start at the project level and then get funneled down to the appropriate app, depending on the URL pattern. All right, so just to keep everything in mind, everything starts at the project level. All right, so now Django folder structure. Use this picture as an example. Think of our project itself as an ice cream freezer in charge of regulating all of the individual flavored ice creams, which each individual ice cream would be an app. Okay, now it goes into the process of actually creating a project. Here is a list of commands that we'll need to utilize to be able to create a project. First, it's walking us through the process of creating a virtual environment. This is activating our virtual environment. We then want to upgrade pip. And we want to install Django, start a new project, which will go about the different ways of creating a project. And then this is how you create an app. If you want to take a screenshot of this, you can. I will make sure to share this inside the demos and notes as well. But this is a short, little quick cheat sheet, you can say, as to, hey, this is how you go about creating a Django project. All right, it looks like there's a little bit of a question section. So let's go ahead and address questions with just the slide deck. And then after that, we'll dive into some code. Go ahead, Alex.
Are we gonna start creating new virtual environments? Or are we just sticking with the one that we started with this entire time?
You're going to start creating new virtual environments here shortly. All right, Rick.
Yes. If so, I think I'm sure we'll go over it, but all the different things that are included in Django, if there's other libraries that we want to add, does it get tricky to add them into Django, or is it the same way as if you were like running a Flash server? Is it just the same?
It's pretty much the same as if you were running a Flash server. You would just install it into your virtual environment and then afterwards just import it straight into your Python scripts.
Okay. All right. So there's nothing else you have to do for Django. All right. Thanks.
Of course. All right. So the next portion of our slide deck is going to dive into part 2 of our lecture. So we'll stop here real quick and let's go ahead and start actually setting up our application. So here's a little bit of a intro to Django ORM. Our entity is going to be creating a Django project that can leverage Django's object relational mapping system to generate data tables within a PostgreSQL database. There's a couple of highlights that I would like everybody to take a look after whenever we're working through this process. Make sure that you're looking at the project structure and execution. If you have questions regarding the project structure and execution, please ensure to say so. Do not let me move on unless your questions have been answered. Same things with the settings database configuration. This is what's going to allow you to actually connect to your PostgreSQL database. What is a model? And then migration files. So these are the things that we truly need to understand by the end of this lecture. Now in part one, we're going to talk about what are we creating. We've already done that. We'll dive deep into Python virtual environments. We'll install Django. We'll then go into creating a Django project, talk about requirements txt, install psycopg3, connect to our database server. We'll then migrate so we can take a look at our database. We'll go into creating an app. From there, we'll actually make migrations and then talk about the Django console versus PostgreSQL, just to confirm that the same data is being shared between Django and Postgres. Does anyone have any questions over the material we're about to cover?
No, can you scroll up real quick to see the highlights? Okay, great. Oh, this is just from the curriculum readme, the lecture.
It shouldn't be in the curriculum readme as of right now, but it is information that we're going to be finding inside of the curriculum readme.
Okay.
All right.
Thank you.
Of course. Okay, so starting off, let's talk about Python virtual environments. If you currently have a Python virtual environment activated, you're going to see it on the left-hand side of your user. It'll say something, it'll be in parentheses, and it'll have something like dot default or dot something else. So in this case, to start off, I want to deactivate that process. In this case, it's going to tell me, hey, there's no command found because I have no Python virtual environment activated. From there, I'm going to just simply create a new Python virtual environment. I'm going to say python -m venv dot venv. Now, when it comes to naming conventions for your virtual environment, you could name it anything you want. I would name it something underscore venv. I would end it with venv whenever you name a Python virtual environment, just so that other developers are tracking, oh, that's a virtual environment. And make sure you always start it with a dot. That dot is going to allow people to know, oh, this is something that's supposed to be ignored. And then it won't be visible within your file system. And then we'll talk about how to make sure that this gets ignored in Git here shortly. All right, so I execute this line of code. Let me go ahead and share that here inside of the Buffalo Questions channel as well. All right. And you can see that there's a .venv directory that has been created. Now, inside of this .venv directory, I can take a look at bin, and there's a couple of scripts that have been added here. So there's the activate script. This is all written in bash. And this is what, when I run source venv bin activate, this is the script that is triggered. And this script is essentially just altering the path to Python so that it's able to find the version of Python 3 that's located down here. All right, that's all it's doing. When I run that activate function, it's saying, hey, I want you to change the path in this machine that we have to Python to the one that I'm currently carrying inside of .venv. And when I run deactivate, well, when I run deactivate, that's when it runs this activate finish. So here's the function deactivate. It exits the virtual environment. It unfolds all the pathing that it did and returns me to my machine's Python environment, not the one that's inside of my virtual. So let's actually activate our Python virtual environment now. So I say source .venv /bin/activate. And now I have .venv on the left-hand side. All right, this source command, I'm essentially saying, hey, update this terminal instance that I currently have to have the following script being activated. And I tell it the information as to where to find the script. It goes into .venv, dives into bin, and executes the activate script. All right, does anyone have any questions over the activate script or how this is functioning for Python virtual environments? Perfect. So now for our next portion, now that we have Python virtual environment installed, we're going to actually update our pip. So I'm going to say pip install -- upgrade pip. Boom. And when I run that command, you'll see that it's actually going to install the newest version of pip. I had 24.2, now I'm up to 25.3. All right. And you can see that it even ran through the process of uninstalling 24.2. It successfully uninstalled it and then installed the newest version. So there's no confusion as to what pip it is I'm currently using. I go into the bin. I still just have pip3. Nothing has really changed here. If I open up include, there's nothing in there. If I open up lib, well, now lib has something regarding pip. Okay, well, let's see what happens when I continue on with my installments. All right. Here I'm going to go ahead and pip install Django. And when I pip install Django, notice that lib has now grown. The directories inside of my lib, nothing inside of include has grown, but inside of this lib directory, I now have this sgirf, I have this Django directory, I have this other Django directory. So to do a flashback to an earlier question, Tom, you asked me, hey, what happens to everything that gets installed? If I deactivate the virtual environment, what happens to that information? Well, everything that we installed still exists. It's just staying within the virtual environment inside of the lib directory. So just like in NPM, we're utilizing node modules to keep track of all of our dependencies, our lib directory inside of a virtual environment is keeping track of all of our dependencies. All right. Does anyone have any questions over installments and how our virtual environment is functioning? Let's hear it, Alex.
I'm trying to do the pip install pip upgrade, -- upgrade, and it's saying there's nothing to distribute to.
Interesting. I'm not sure what you're getting that command from. We would have to debug it on the side. I just shared the command here inside of the Buffalo Questions channel,
Okay.
but I'm not sure where that would be coming from.
Okay.
All right. So now I have a new virtual environment that's been installed and activated. I have installed Django. So let's make sure that we share that as well. So and now that I have installed Django, I can actually create a Django project. Now there's a couple of ways of creating a Django project. Our Django project is going to create the Poke API. We're going to try to mimic the Poke API structure and try to create something that looks a little bit like this. We're not going to go as far as in depth as to describing everything that's in here because it's a pretty massive data structure, but we're going to create a couple of tables that will help us relate to this API. So with that said, I'm going to start a project named the Poke API. I'm going to say Django admin start project. I'm going to name it Poke API project. And I can execute the command just like this. If I execute this portion, you're going to see that a new Poke API directory has been created on my left-hand side. Now, this Poke API directory has a Poke API project, so it's kind of nested and repeated. And that's what's holding my manage.py. It's holding settings.py and so on. So if we were to do a little bit of a flashback to how information is being rendered. Everything starts at the project and then falls to the apps. We're starting at the project level, which is this Poke API directory. Executing all of the code in here, and then it would manage to go to all of the apps, which we'll talk about here shortly. This manage.py script is a shell script, or excuse me, it's a Python script that essentially allows us to execute any commands that have to do with this one project inside of Django. So you'll see here shortly how all of the commands are going to be passed to this manage.py. It's going to capture our input, and from there pass it into this execute from command line function. All right. So again, one way to start our Poke API project is by simply stating Django admin start project, Poke API project. Let me go ahead and remove that. Another way to start a project would be Django admin start project, Poke API project. But in this case, I'm going to add a period at the very end. And by adding a period at the very end, I'm saying, hey, instead of creating a parent directory, I just want you to utilize the current directory that I'm in to create this project. And now, Poke API project is not nested. You can see manage.py is directly accessible to me. And this Poke API project already has settings.urls installed within it. So there's the two different commands that you can utilize to start a Django application. A period will not create a nested directory. Missing a period would create a nested directory for your application. Very similar to B. I'm going to remove this project for now. I'm going to actually create it inside of a nested directory. So I'll say Django admin start project API, or excuse me, Poke API project. All right. Does anyone have any questions about how to create a Django project? Okay. Oh, go ahead, Arnold.
So just to recap, so without the dot, we'll create a nested directory. With a dot, we'll not create a nested directory.
That's correct. Yes,
Thank you.
of course. Let's hear it, Alex.
I don't think did I have my hand up?
Oh, sorry, Chris. I apologize.
Yeah, I was just curious. I know you're using Django admin. Would you always want to create a project like that using the admin, or when would you not use Django admin?
There is a separate command that you can utilize utilizing Python-M. It does create every now and then, it may create some misbehavior. So the preferred way of doing it is just utilizing Django admin after Django has been installed. All right, Sam?
Yeah, is there any reason we would want to create it as a nested directory? Is there like an advantage to that?
That's going to be design structure. So, for example, here, I already have a .vmv environment on the outside. That's a directory. I have this Poke API project. It's a directory. I would rather everything be isolated inside of the Poke API project. So I would always have it nested inside of a directory. Um, Specifically because I also want to add a README and not have everything jumbled up inside of one another. It's just kind of preference. It doesn't really have any sort of dictation as to this is when you should and this is when you shouldn't. Does that answer your question?
Yes, thank you.
Of course. All right, Alex.
So what would you consider the root project folder? Would it be the one dash intro to Django dash ORM, or would it be Poke API project folder?
Yeah, it's a great question. So this Poke API project would be considered the root. This secondary Poke API project would be the actual project of execution. And then manage.py would be a script that belongs to the project. Does that answer your question, Alex?
Yes, and would you want your root project to be in the same, I guess, level as your virtual environment? Is that best practice?
Again, I think that's just going to depend on how you want to structure it. When it comes to best practices for virtual environments, what I have is actually a directory within my root user named environments. And in here is where I keep all of the different virtual environments that I keep track of. Now, the main reason why I do that is because if I just put them inside of nested directories, at some point, my machine is just going to have a ton of virtual environments that I'm not going to keep track of. And then when I try to clean up my machine or remove them, it's not that it's so heavy, but you definitely don't just want to leave a bunch of miscellaneous virtual environments all over your machine. Does that answer
Got
your
it.
question, Alex?
Yes, thank you.
Of course. All right. Okay, perfect. So it looks like we got our folder structure down. We understand how everything's being created. And now we can actually take a look at our Django project and talking about requirements.txt. Okay, so in Poke API, or excuse me, in my .venv, if I go into my lib directory, I now have a couple of dependencies. So far, it's just Django, sgrf, and a little bit of pip dependencies as well. Well, this information needs to be tracked somewhere. And it needs to be able to be shared with other developers, right? Because other developers that are working within the same project may need to be able to just install quickly all the dependencies that are within this project rather than hunting each one down. I'm not going to be sharing my virtual environment with them. Instead, I'm going to be sharing with them a list of dependencies. Well, how can I do that? Well, in Django, we have a command named, or excuse me, in Python, we have a command named pip freeze. Now this gives us back a list of all of the dependencies. So you can see that by executing pip freeze, I can get sgrf. It tells me what version it is that I'm holding, SQL parse in its current version, and Django in its current version. Well, that's nice, but how do I get this into something that I can share with everybody? Well, this is called requirements.txt. I can say pip freeze, and this arrow here is going to allow me to write a file. I'm saying, hey, I want you to place all of this output inside of a file. And that file is going to be requirements.txt. Again, pip freeze is just providing this output. In bash, I am saying place the output of this command into this file named requirements.txt. Well, when I open up requirements.txt, there I have that entire output that has all of my dependencies. And this is the file that I'll be sharing with other developers so that they can quickly just run, hey, I want to pip install -r requirements.txt. So I'm going to pip install in a recursive manner requirements.txt. It will start at the very top line, install it, and then utilizing recursion, work its way down through all the dependencies. When I execute that line of code, in my case, it's going to tell me requirements are already satisfied. All right. Does anyone have any questions about how we created requirements.txt and what the purpose of requirements.txt is? Doesn't seem like we have any questions, so I'm going to go ahead and keep pushing forward here. We've talked about requirements.txt. We've already developed a Django project, but now let's talk about how to actually connect to a database. Well, the first thing I'm going to do is I'm going to actually create a database. So I'm going to run create db, and the database that I want to create will be the Poke API DB. So I'm going to create the Poke API database. That's going to happen inside of PostgreSQL. Now I can bring up a separate terminal and enter it. So I'm going to say PostgreSQL Poke API DB. And you can see that I've entered the Poke API DB. If I run \d, it's going to tell me there's no relationships found, which is perfect. That's what I expected because I have nothing connected there yet. But I want to connect this to my Django project. Well, in order to connect a database to our Django project, we have to actually specify to Django how to find this database. Just like we did in Flask when we were utilizing SQL Alchemy, we had to specify the address of, hey, this is where you're going to be able to find this information. Projects can be a little bit, or excuse me, Django's can be a little bit simpler as to the setup for being able to find your database. Settings.py is going to hold all of the configuration that you need for your project to be able to run successfully. So you can go into settings.py, and if you scroll down, we're going to go over each one of these variables later on and what they stand for. But here we have a secret key. If we continue to scroll down, there's a little bit of middleware, installed apps. Again, we're going to be going over all of this later on. But here we can get to something called databases. And you'll see that there's a dictionary that gets provided to us. In here, there's a default key. So it's saying, hey, by default, utilize this database. So this tells me a little bit of, well, what else can be placed inside of this databases portion. All right, we can read the Django documentation. You can have a default, you can have a backup, a couple of other things fall inside of this dictionary. But here in Code Platoon, we're just going to cover how to overwrite this default database. Now, currently, it's saying I want to utilize all of the Django backends module to speak to an SQLite database or RDBMS, right? Well, that's not what I want. I actually wanted to speak to a PostgreSQL relational database management system. So I need to make sure that I update line 78 to state, hey, the database that you're going to be speaking to will be of PostgreSQL. And then finally, all I need to do is specify the name of this database. So the name of this database is going to be Pokey API DB. Now, there is a lot of assumed values. For example, there's host, which in this case, the host is localhost. There is port, which in this case, the port would be 5432. There's user, which in this case, the user would be Francisco Avila. And then finally, there is password, which password, if not provided, it would be assumed to be none. Or actually, it wouldn't run it as none, it would run it as empty. So all of these are assumed values. That doesn't mean that we're not passing them in. They're still being passed into the project. It's just we don't have to manually write them out, right? Now, this could be important because when we go to deployment, well, in deployment, our host may be something like an actual address that's being held within AWS. And we may want to utilize a different port if we wanted to. Could switch ports for security purposes. And the user during production may be a company-wide user. And there may also be a password that's applied to this company-wide user. All right, so that's a couple of reasons why these parameters are available to us. This is how we would actually connect to our database. But there's one more thing missing. When we installed SQL Alchemy and we attempted to talk to SQL Alchemy with Flask, do we remember what kind of errors we were encountering and why those errors were coming up? Well, the next thing that I need, if I take a look at this diagram that I wrote up here, well, we know that RDBMS comes back, or a relational database management system is going to come back with a query. But that query needs to be something that's accessible by Python. So something along the way needs to make the interaction or the switch from, hey, this is an SQL output to this is a Python information. Well, that's going to be happening through PsychoPG. All right, so PsychoPG is essentially your translator that turns all of our SQL queries into Python language. So again, I'm going to go back to my my bash here. I can see my virtual environment is still activated. I'm just going to simply run pip install psychopg3, or excuse me, psychopg binary, which is the official command for psychopg3. Let me make sure I share that with all of us inside of Buffalo questions. And when I execute that line of code, well, now I have psychopg available to me. Now, because I've updated my dependencies, I probably also want to update my requirements. All right, so I can say pip freeze requirements txt. And now you'll see that we've also added SQL parse, psychopg binary, and psychopg. My dependencies are being tracked. My settings.py is ready to go. But how do I actually make sure that this is connected to my database? Well, now it goes into the actual script portion. I can run Python manage.py, and actually I need to change directory into my Poke API project. Now I can run Python manage.py, and this manage.py is just going to capture the input as arguments and pass it into this execute command line function. And this execute command line function is going to grab those arguments as a list of string and pass it into the body of the function. Unfortunately, it's not giving me more information as to what this function looks like. That's fine. I could at least see that there's some logic going on here, right? It's going to grab my input and conduct some sort of action, but it won't return a value. Okay, it's good for me to know. So I'm utilizing Python to execute the script of manage.py. Now, the command that I want to run is going to be migrate. And this migrate command is going to grab all of my dependencies for my project that need to be tracked inside of a database and place them inside of SQL. So currently in SQL, if I run \d, there's nothing in there. And this is where the batteries included is really visual. I'm going to run this command. And when this command is executed, you can see that it's thinking for a second and made that initial connection to the database. And here's all of the information that it just migrated into my database. Well, it made an authentication portion. It created a couple of admin entries. This .00 just means the sequence as to how those entries were created. So there's 001, 002, 003 for admin. For authentication, it then continues. So here's the initial one of 001. And then authentication continues to move it down all the way until 12 different entries. A lot of them were altered. And you can see that it has to do a lot with permissions. And then finally, there's a sessions that gets installed. Well, just recently when I ran \d to take a look at all my relationships or all the different data tables inside of this database, it gave me there was no relations. But now when I run \d, I can see plenty of relations have been created, all through that singular command in Django, where I got auth group with some sequence. I see the Django admin. All of this is just already provided to us by Django because it knows it's something that we're typically going to need whenever we're trying to create a web server. All right. So now we went over a lot of commands. So let me do a quick recap before I open it up for questions. When installing our database process, we went ahead and grabbed the databases inside of the settings.py. We specified the machine that we're going to be working with will be of PostgreSQL, and then specified the name of the database that we had just created of Poke API DB. We then installed psychopg3 and updated our requirements to psychopg3. And then finally, we utilized the manage.py script to simply migrate all of our already built-in migrations by running Python manage.py migrate. All right. Does anyone have any questions over how we connected to our PostgreSQL database and how we migrated all of our dependencies, or excuse me, all of our different tables into our database? Let's hear it, Alex.
So to migrate all the dependencies to the database, basically just the last part, the way you did it was simply just run the manage file.
That's correct. With
There
the
was
migrate.
there's no copying. I don't know if I was watching or taking notes, but there was no copying and pasting anything from settings.py to manage.py.
No copying
Okay,
or pasting at all.
thank you.
Of course. All right, go ahead, Arnold.
Yeah, and to add on what he said, so in order for us to do all this, we always have to check the settings.py file first and find the database and make
Yes,
sure
that's
that it's Postgres SQL. And if not, we just manually edit it.
right. Make sure that it's it's never going to be by default at PostgreSQL. Every time you create a project, it's going to be defaulted to SQLite. So you'll have to come down to databases and change this information.
Okay, thank you.
Of course. All right, Alex, is that from before or do you still have a question?
That's from before.
Okay. All right, perfect. Okay, great. So a little bit of magic going on now, right? There's some information that's going on. That's the beauty of Django. It comes with batteries included, so now I don't have to worry about all the unimportant stuff that I need to create in order to have my server running. It's already being managed for me. Well, now that I created this settings.py, let's start talking about, hey, what happens when I create a Django app? And then we'll start making a model and actually place it inside of Django. We may go a little bit over time. I do apologize, everyone, but I'll try to speed up the process a little bit here. So now to create a new app, we're simply just going to run Python manage.py start app. And this app is going to be, or this command is going to be followed by the name of the application that I want to create. In this case, I want to make a Pokemon app. And also notice the naming conventions that I'm utilizing. When I created the project, I named it underscore project. And now that I'm creating an app, I'm naming it underscore app. All right, so just a key thing to make sure you highlight there. It's not going to break anything if you don't do that, but it is a convention. All right, and now we have a Pokemon app that has been created. Now, this Pokemon app has something like migrations. Well, I don't know what that is just yet, and we'll talk about that here shortly. It has this admin file, which is completely empty, and the majority of these files are going to be empty. It has this apps file, which is just a configuration for this specific app, and it gives me an instance of a class. So notice how app config is a class that's being inherited by this Pokemon app config. Right? And then from there, we can just change some of the different values that are being passed in there. All right. We have our models file, which is going to be where we're going to do the majority of our work today. There's a test file where we can always write tests because we love testing so much. And then we have a views file, which is where we're going to write all of the functions that will return responses to a front-end server. All right. So now that I've created this app, although I've created the app, it is not connected to my project just yet. And, well, why, right? What's the whole point of creating the app if it's not going to be automatically connected? As of now, I'm not entirely sure why it's not automatically connected, but you do have to manually go into settings.py, scroll up into the section named installed apps. All of these apps have already been created and installed for us automatically by Django. Again, batteries included. But here we're just simply going to add the name of the application, Pokemon app. And just to make sure that you don't ever forget, always end any entry in here with a comma, even if it's your last entry, always add a comma. All right, so here's our Pokemon app that has been installed. So now when data flows and it goes into the project, it's going to say, okay, well, inside of settings.py, inside of all my installed apps, what apps do I have available? All right. So now it knows that these are the apps that it has available because it's able to find them within the section of installed apps. Right, so that's the only reason why it's able to find it. If it's not within the list of installed apps, the project is unaware of the existence of that application. So you have to ensure that you add it. All right, so here's my Pokemon app. It has been officially added. Now let's go through the process of working with this information. I'm going to come down here, go into my Pokemon app, and open my models. Now this models, you can see that it's coming from Django.db. And what I want to do is I essentially want to create a table for a Pokemon that's just going to have two entries or two fields. It's going to have a name and it's going to have a level. A name will likely be something like a varchar, right? And then a model would be something like a number or an integer field. So how would I go about creating that in Python? Or more specifically in Django's ORM? I would actually create a new class. And in this case, I would name it Pokemon. And this Pokemon class would then have something like, hey, I want to have a name, which would be equal to a string, and I want to have a level, which would be equal to some sort of integer, right? And if we wanted to go through the entire process, we could say self or df init, where I pass in self, name, which is a string, and then level, which would be an integer, and this would return none. Right? I could then change these to be self.name, self.level, and then update them to say, hey, this is going to be of level, and this is going to be of name. Right? So this is standard OOP. This is how we usually write it. But I don't want to just write a class here. I want to write a data table. So in order to turn or convert a class onto a data table, I have to utilize models or inherit from models.model, where the model class turns class onto a data table. All right. So again, I would utilize inheritance here. And I would simply say models.model. That's what's going to turn into a data table. Well, with that said, my initializer would then no longer be necessary because what I'm creating is a data table. Instead, what I want to create is fields. For the data table. So I'm just going to simply comment this out. And instead, I'm going to create, hey, well, I want a name, which I'm being provided models, which is an entire module. If I take a look at models here, you'll see that all of this information is being provided for us. There's foreign key relationships, there's image fields, JSON fields, there's a ton of fields that we're going to be talking about in the second portion of our lecture. So here I can just say, I want to utilize models.char field, which would be a string. Notice this is still a class. So at this point, I am utilizing composition to be able to make an entry here. There's a couple of values that we can pass into char field, but as of right now, we're just going to keep it nice and simple and not add anything else in there. And same thing for our level. We could create a level and make that a models.integer field. which again would utilize composition. So here we're utilizing inheritance, while down below we're utilizing composition. Now let's see the full execution for this before we actually open up for questions. I now have a table. My application is tracking on this table. But there's currently no migrations that are to be applied. If I run Python manage py migrate, you'll see that it's going to tell me, hey, your models and apps, Pokemon app, have changes that are not yet reflected in migrations, and so won't be applied. And it gives me a message here, no migrations to apply, which is actually really cool because this message didn't used to exist. So this is this is a newer version of the Django that we're working with, which is awesome because this used to drive me crazy. All right. And then it tells me, hey, run manage.py, make migrations to make a new migration, and then rerun manage.py migrate. So it's quite literally giving me a walkthrough as to how to create this information. So let's see what happens. You can run Python manage.py, make migrations. And when I run make migrations, notice that it's saying, hey, inside of Pokemon app, in the migrations directory, I've created an initial file. And it's saying that the initial file that it's creating is create model Pokemon. Well, now if I take a look at migrations file, before this was empty, all I had was the init.py script, but now I have this 001 migrations. Well, let's take a look at what's going on here. Well, that took my model and it turned it into a migrations file. So this is a class of migrations. It's telling me this is the initial input. So there is no dependencies. You'll see that this dependency list is empty. And here are the operations that it's going to execute within SQL. It's going to say, hey, inside of SQL, I want you to create a model or create table. This table is going to be named Pokemon. And the fields that you'll be created are as follows. As of now, SQL doesn't have any information, none of this information. I can run select all from Pokemon, and you'll see that it tells me, hey, I don't know what you're talking about. There's no such thing as Pokemon just yet. Okay, well, when I run Python manage py migrate, that then grabs this migration file of Pokemon app 001 initial, it successfully migrates it. If I run \d and scroll down to the bottom, you'll see that I now have my Pokemon app that has been generated for Pokemon. And now I can simply say select all from Pokemon app, Pokemon, and you can see that it comes up with ID, name, and level. Here's the ID field, which is being automatically provided for us, the name field, and level. All right. And let me go ahead and open it for questions because I already see a couple of hands up, but I will run a recap over this information here shortly. Go ahead, Tom.
Just a few things. Can you scroll to the right a little bit for ID? Because does that mean the ID is being created as a serial? Oh, okay. So from right there, we can tell it here. Would we need to set it up here to make it a serialized ID, or would we need to do that um, in our model creation um, to establish like, hey, I want to give it an ID versus serialized?
Yeah, that's a good question. So if you want to give it an ID, you would actually specify it here instead of a model creation. Otherwise, it's going to automatically generate it, and it's already going to be a serialized ID, meaning that every single time a new entry comes in, it will increment the number. I see that it says serialized false here, but this may be a misconception as to how they're naming their fields. This isn't for, hey, I wanted to increment every single time there's a new entry. This is for, I want to encrypt it when the ID is being generated. And I see the clarification there. Did that answer your question, Tom? Okay, awesome. Go ahead, Alex.
To migrate, you would have to do initially Python manage.py make migrations and then migrate to bring the data over to your database.
That's correct. Yes.
Okay.
All right. So migrate will always migrate is the command that communicates to your database, and migrate looks for these migrations. If there is no migrations file that hasn't been implemented, migrate just says, "Hey, there's nothing for me to execute because I'm all up to date." All right. So I have to run make migrations to create a new entry of this file and then migrate to actually communicate to the database and for migrate to identify there's been a change since the last time I communicated to the database.
And,
So
and the way you're adding these files is through the models file.
that's correct. Yes.
Okay. Okay. And then real quick, I guess, the syntax of it all char field. So this isn't the same language as like an SQL.
That's right. Yeah, and we'll talk about fields here in the second portion. So this would be like varchar, and this would be like I think it's called an integer field inside of SQL.
Okay. Thank you.
Of course. All right, Rick.
Yeah, real quick question is just um, so you said serialized if it's true. You mentioned encrypted. Um, I was reading and it was saying that uh, uh, the Django will um, create a hash for like passwords and stuff like that. But my understanding is it would not be able to like do like a standard encryption. You'd have to like download a different library for that. Are you telling me that Django does have like an encryption algorithm?
It doesn't necessarily have an encryption algorithm. It just tries to mimic that kind of behavior rather than utilizing just integers. I don't recommend changing any values in there. Instead, what I recommend utilizing if you're looking for something like that would be utilizing a UUID, and you would just have to install that package separately.
Yeah,
Does that answer your
okay.
question, Rick?
That's what I thought. Yeah, that's what I thought. It's just when you mentioned serialized true and false was like encrypted, I thought maybe Django had like an encryption algorithm. So, all right, thanks.
Of course. All right. Well, now that we finished this process, we were able to create a new Pokemon, or excuse me, that we were able to create a database entry. Now let's actually create a Pokemon, right? Our entire Pokemon project is up. We can see all of this. All of our requirements are up to date. Fantastic. I have a model. How do I interact with all of this? Well, for simplicity's sake, I'm going to create something called a playground because I don't want to have to reinstall everything every single time I run this file, and you'll see what I'm talking about here shortly. And here I'm going to simply say from Pokemon app dot models, I want to import Pokemon. And for Pokemon, this is still OP, so I want to create a new Pokemon. Let's say new Pokemon is equal to Pokemon. And I could pass in a couple of values here. I can say, hey, I have where name is equal to, let's do Pikachu, because why not? And let's do where level is equal to 22. Now this is still OOP, but there's a little bit of syntax difference here. This is going to basically mimic a writing of the class, but it's not going to actually write it within our database. In order to actually write within our database, I would have to say new Pokemon dot save. Now this creates an entry onto the database. Now I created this Python script named Playground, but how do I actually execute it within the concept of Django? Unfortunately, getting an outside script to be executed without a Django is quite difficult, and the juice just isn't worth the squeeze. So instead, what we utilize is something called the shell. So I'm going to run Python manage py shell. And this takes me into a Python environment. Here I can say, hey, this print hello. The only difference between the shell and the regular Python script that I could open up inside of a Python environment is that I have access to everything within Django as well. So now I can execute this entire script. I can Command C and Command V. And when I press enter, if I try to print new Pokemon, you'll see that it tells me, hey, this is a Pokemon object at 1. And when I run my select query, my select queries tell me, hey, there has been a new Pokemon that has been installed. Its ID is of 1, its name is Pikachu, and its level is 22, just like I dictated up above. Again, this creates a mimic of the class, but doesn't actually write. This is what saves my class and creates an entry into my database. If I go back into my shell script, I can say, hey, I want to print new Pokemon dot name, and that would return Pikachu. And same thing for the other attribute. I can do new Pokemon dot level, that would also return 22, and I can print new Pokemon dot ID to see its ID value is of 1. So all of the data within my Python and shell script is also matching the data within my database. All right, again, we have to utilize the shell to be able to interact with everything inside of Django. To be able to access the shell, we run python manage.py shell. That gives me an entire Python environment, but it allows me to also interact with information inside of my Django application. I simply import from the directory of Pokemon app in the file models, the class name Pokemon. I create an instance of that class. So this creates an instance of the class. But doesn't write onto the data table. And this down here of .save is what writes onto the data table. All right, does anyone have any questions over how we were able to create a new Pokemon and save it both onto our data table as a new entry and have it accessible within Python? Go ahead, Tom.
I guess I'm just confused as to why we did it in the playground and then again in the shell. My assumption is that you use the playground as the staging area to get basically as like a notepad to copy and paste to the shell. Is that correct?
That is correct. Yes. I'm basically just utilizing the playground as a, hey, this is where I'm going to write all my code, but everything's going to be executed inside of the shell because only the shell has access to everything inside of the project itself. If I try to execute this playground, it's going to bring me an error. So let me try to demonstrate it here. So source .vmv slash bin slash activate. Cool. And then let me change directory into my project. So you see how if I try to utilize it here, it tells me, hey, this is not within an installed app, so you can't just execute something like this. And if you want to do it, you have to go through the process of setting a configuration and just changing a bunch of things inside of Django. It's just the juice isn't worth the squeeze in order to get a Python script that I can actually execute. So instead, I just keep all my information in here inside of a playground so that I also have something to push up into demos and notes. Does that answer
Gotcha.
your question?
Yeah, a little bit. I guess I was just confused because I thought you were able to query the database and pull that information before you actually opened the shell. Or I might just be getting it backwards because I was doing note taking and watching at the same time. So I don't know when you actually queried the database and pulled that info
Yeah, so
to the process.
that happened after the shell. So I wrote this information, executed it inside of the shell, and then afterwards I queried the database.
Okay.
All right. Alex, you're still muted.
What's the location of playground.py? Is that outside of the project right now?
So it's inside of the root directory adjacent to the project file.
Oh, okay. And so that doesn't have access to the project file or folder.
It has access to the project folder, yes. So in here, the playground is next to manage.py. If I wanted to access something from the project folder, I would just simply say from poke API project.settings.py. I could import something like databases.
Okay. And would you have to do that every time? For I know playground.py is for, I guess, teaching purposes, but um, would you have to like copy and paste every single time an instance was made
So that's a
into
great
the shell?
question. Yeah, that's a great question. Let me actually demonstrate what happens here. So let's say I want to exit the shell, right? I could just simply run exit. Okay, so now I exited the shell. And I go back into the shell. If I wanted to graph something like Pokemon, well, I could say, hey, new Pokemon, I want you to print new Pokemon dot name. Well, that's going to tell me, hey, there's no such thing as new Pokemon because now I have exited the script. There's no memory that's being shared between each shell instance, right? It doesn't even know about the class of Pokemon just yet. I would have to re-import. I would have to say, hey, from Pokemon app dot models, import Pokemon. Then I would have access to Pokemon. And then I could print, let's just say the Pokemon class. And that would tell me that this is a class of model named Pokemon, right? But again, if I were to exit and re-enter, if I do print Pokemon, it doesn't know. Oh, it was actually able to know about it. Interesting. There's no, this is going to create confusion. I apologize. But there's no shared memory between each one of them. As you're executing lines of code and having creating new variables, every single time you close the shell script, that's where the memory ends. Right. So to make sure that I have some consistency, I'm keeping it all in here inside the playground. Does that answer your question, Alex?
Yes.
All right, Tom.
So would you say this is kind of like our own version of Git for Django, and the fact that this is where we can basically store all of our commands and everything that we've ran in shell to access at a later date?
I get your analogy, and yes, we could say we. I think that would be a good statement there.
Okay.
All right. Any other questions? Okay, awesome. So let's quickly do a recap over everything that we've covered today. So in part one of our lecture, we covered Python virtual environments, how they work, and how to isolate our dependencies utilizing pip freeze. We covered how to create a Poke API project. This project, how the root directory holds a project. We can create apps and manage.py. Inside of our projects, we went over settings.py. We talked about installed apps, ensuring that any apps that you create get added into installed apps. And we also talked about the configuration of our databases to ensure that we can connect it to a PostgreSQL database. We connect it to our PostgreSQL database, dictate what database it's going to be speaking to, which in this case is the Poke API DB. And then inside of our app, we generated a model that inherits from models.model and then creates a char field and an integer field for each one of them. We utilize this file to then make migrations, which make migrations is essentially the operations that it's going to execute in SQL. And when we migrate, we leverage CyclePG3 to speak to our PostgreSQL database, or excuse me, our Poke API database, and actually write a data table named Pokemon with the fields of ID, name, and level. From there, we simply utilize the shell. And with the shell, we were able to grab the Pokemon class, create a new Pokemon instance, which does not write, and save it onto our database, onto our data table, which is what actually writes onto the data table the entry of Pikachu and level 22, which we can see here. At this point, does anyone have any questions over any of the material that we covered over part 1? Let's hear it, Rick.
It's more of asking. I'm gonna I'm gonna need to like watch some of the stuff again. Is this gonna be uploaded probably like tomorrow or something?
No, it'll be uploaded this afternoon at the latest.
Okay, cool. All right, because I'm gonna need to watch this again.
Absolutely. All right. Any other questions? Okay, awesome. In that case, I'm going to go ahead and stop our recording here.